Picture this. Somewhere along China's eastern coastline, in a massive shipyard shielded from satellite surveillance, the future of naval warfare is taking shape. For years, whispers circulated through defense circles about an impossible project, a nuclear-powered aircraft carrier that would vault China decades ahead in maritime technology. Most dismissed it as fantasy. After all, building a nuclear carrier isn't just about welding steel plates together. It's about mastering some of the most complex engineering challenges humanity has ever attempted. But in 2024, those whispers became roars. Satellite imagery captured something extraordinary. Intelligence reports started flooding in, and suddenly, the impossible seemed not only possible, but imminent. Today we're diving deep into one of the most significant military developments of our generation, China's Type 004 aircraft carrier. This isn't just another warship. This is a vessel that could fundamentally reshape global power dynamics, challenge American naval supremacy, and signal a new chapter in modern warfare. If you're interested in geopolitics, military technology, or understanding how the world order is shifting beneath our feet, make sure to subscribe and hit that notification bell. You won't want to miss what's coming next. Let's begin. Back in 2023, when reports first emerged about China constructing its fourth aircraft carrier, and not just any carrier but a nuclear-powered one, the international defense community reacted with widespread skepticism. Military analysts, naval experts, and even casual observers questioned whether such a leap was technologically feasible. Their doubts weren't unfounded. Consider the timeline. The United States Navy commissioned its first aircraft carrier back in 1922. That was the USS Langley, a converted coal ship that could barely launch a handful of biplanes. It then took America nearly 4 decades, 38 years to be exact, before successfully launching the USS Enterprise in 1960, the world's first nuclear-powered aircraft carrier. 4 decades of trial and error, technological refinement, and accumulated expertise. Now compare that to China's trajectory. The People's Liberation Army Navy commissioned its first carrier, the Liaoning, only in 2012. That vessel wasn't even built from scratch. It was a refurbished Soviet-era carrier that China purchased and renovated. At that point, China had virtually zero experience operating carrier-based aviation. Fast forward to today, and we're talking about just over 20 years of carrier development. The mathematical logic seemed clear. If it took the United States, with all its industrial might, engineering prowess, and wartime experience, nearly 40 years to develop nuclear carrier technology, how could China possibly accomplish the same feat in half that time? Even among Chinese military enthusiasts, skepticism ran high. Online forums buzzed with debates. Many argued that China would need to build at least 1 or 2 more conventional carriers before attempting the nuclear leap. The technological gap seemed too vast, the challenges too complex, the timeline too compressed. But those skeptics underestimated something crucial. China's approach to technological development in the 21st century operates under entirely different parameters than Cold War-era America. Throughout 2024, a series of revelations began to change the narrative entirely. What had seemed like speculation started transforming into documented reality, piece by piece, like a puzzle gradually revealing its complete picture. The first breakthrough came from space, literally. Commercial satellite operators, whose high-resolution imaging capabilities now rival military reconnaissance, captured aerial photographs of a Chinese shipyard. What they revealed was stunning. The skeletal framework of a massive vessel, its dimensions comparable to the largest carriers ever constructed. The images showed a ship under construction with proportions that dwarfed China's existing carriers. Military analysts immediately began studying these photographs with intense scrutiny, measuring pixel by pixel, comparing proportions, calculating dimensions. Their conclusions were remarkable. This wasn't just another incremental improvement over the Fujian, China's third carrier. This was something categorically different, a vessel designed to compete directly with America's newest Ford-class carriers. Initial estimates place the carrier's length at approximately 335 meters, roughly 1,100 feet, with a beam width of around 83 meters. To put that in perspective, that's longer than 3 football fields laid end to end, and wider than a 6-lane highway. The flight deck alone would cover an area equivalent to several city blocks. But size, while impressive, wasn't the real story. The real revelation came from what analysts didn't see. Then came the second piece of evidence. American intelligence sources, later confirmed by media reports, revealed that China had been developing and testing a specialized marine nuclear reactor. This wasn't a theoretical design or a paper concept, this was hardware. Actual physical infrastructure for testing ship-based nuclear propulsion systems had been identified and photographed. The specifications were telling. The reactor reportedly measured 10 meters in diameter and 15 meters in height, dimensions that aligned perfectly with what would be required for aircraft carrier propulsion. More significantly, intelligence assessments indicated that this reactor design could generate approximately 125 megawatts of power. To understand what that means, that's 25 megawatts more than the reactors powering America's Nimitz-class carriers, which have served as the backbone of U.S. naval power for generations. This wasn't just matching American technology, this was potentially exceeding it. But perhaps the most compelling evidence came from an unexpected source. A Chinese shipbuilding corporation publicly displayed a detailed scale model of what appeared to be the Type 004 carrier at an industry exhibition. Now, you might wonder why this matters. After all, companies display conceptual models all the time. But in the highly secretive world of Chinese military development, such public displays are never accidental. Everything is carefully controlled, deliberately released, strategically timed. When something appears publicly, it's because officials want it to be seen. And what observers saw in that model was extraordinary. Eagle-eyed military enthusiasts and professional analysts immediately noticed something absent from the design. There was no funnel, no exhaust stack, no chimney protruding from the island superstructure, the vertical command tower that rises from every conventionally powered carrier ever built. This absence was thunderously significant. Conventional carriers burn fuel oil to power their turbines, which produces exhaust that must be vented through massive funnels. These structures are iconic features of traditional carriers. You can spot them from miles away. Their absence means only one thing. The ship doesn't burn conventional fuel. It's nuclear-powered. This single design detail, visible in a publicly displayed model, confirmed what intelligence agencies had been suspecting and what skeptics had been denying. China had successfully developed nuclear propulsion technology for aircraft carriers, and they were confident enough to essentially announce it to the world. The implications were staggering. Understanding nuclear carriers. Why do they matter? Well, before we go any further, let's talk about what makes nuclear-powered aircraft carriers so significant. Why does this technology matter so much? Why has the United States invested hundreds of billions of dollars developing and maintaining these vessels? And why should anyone care whether China has them or not? The answer lies in a concept military strategists call power projection. A conventional aircraft carrier, powered by diesel or other fossil fuels, is basically a floating city with a short leash. Even though these ships carry thousands of tons of fuel, their practical operational range is about 22,000 kilometers before they need refueling. That might sound like a lot, but when you're patrolling vast ocean expanses, trying to maintain a presence in distant waters, or responding to crises on the other side of the globe, that range becomes a pretty severe limitation. Conventional carriers always have to think about fuel reserves. They need supply ships following them around, which creates vulnerable logistics chains. Their movements are planned around refueling schedules. In combat situations, commanders must calculate whether there's enough fuel to complete the mission and return safely. They're powerful, but they're tethered. Now, consider a nuclear-powered carrier. after a single refueling of nuclear material, a process that typically happens just once every 20 to 25 years, these vessels can travel up to 2 million kilometers. Let me repeat that, 2 million kilometers. That's like circumnavigating the Earth 50 times without refueling. Or to put it another way, that's traveling to the moon and back nearly 3 times. But it's not just about distance, it's about freedom of action. A nuclear carrier doesn't need fuel tankers shadowing its every move. It doesn't have to worry about fuel consumption when deciding whether to launch aircraft, run its defensive systems at maximum capacity, or sprint at top speed toward a crisis zone. It can operate at maximum efficiency indefinitely, limited only by the human endurance of its crew and the food supplies it carries. This translates into something military planners call unlimited endurance for practical purposes. A nuclear carrier battle group can position itself off any coast in the world and remain there for months, even years if needed, without logistical support beyond food and spare parts. It can respond to threats immediately without calculating fuel reserves. It can maintain aircraft operations around the clock without power concerns. In essence, a nuclear carrier is a sovereign piece of territory that can appear anywhere in the world's oceans, bringing with it the full military, diplomatic, and psychological weight of the nation that operates it. Currently, only 2 nations possess this capability: the United States, with 11 nuclear carriers, and France, with 1. These vessels are the ultimate expression of naval power. Mobile air bases that don't require permission from any foreign government to operate, that can't be denied access through diplomatic pressure, and that can exert influence across hundreds of miles of ocean and coastline. If China successfully deploys nuclear carriers, it joins this exclusive club. More than that, it gains the ability to project sustained military power across the Pacific, into the Indian Ocean, and potentially beyond. It gains the ability to maintain a permanent naval presence near crucial shipping lanes, contested territories, or potential flashpoints without the logistical vulnerabilities that plague conventional fleets. This is why the Type 004 carrier matters. This is why Pentagon analysts are paying attention. And this is why this development represents not just a military advancement, but a potential shift in the global balance of power. So, what exactly are we looking at? What capabilities will this vessel bring to the table? Let's break down what we know and what we can reasonably infer about the Type 004 aircraft carrier. Based on satellite imagery and the subsequently revealed model, analysts have pieced together a fairly detailed picture of the ship's specifications. As mentioned earlier, the estimated length is approximately 335 meters with a beam of 83 meters. But, dimensions alone don't tell the full story. It's what those dimensions enable that really matters. The displacement, basically the weight of the ship, is estimated at around 115,000 tons when fully loaded. To put that in context, that exceeds the displacement of the USS Gerald R. Ford, which is currently the largest warship ever built, coming in at about 112,000 tons. We're talking about a vessel that would be, ton for ton, the largest aircraft carrier on the planet. That massive deck space translates directly into aircraft capacity. Military analysts estimate the Type 004 could carry and operate more than 80 aircraft, a mix of fighters, early warning aircraft, helicopters, and drones. That's a complete air wing, capable of conducting complex, sustained operations far from Chinese shores. The carrier appears to feature 4 electromagnetic catapult systems. This is significant because China only recently demonstrated this technology with the Fujian carrier. Electromagnetic catapults, often called EMALs, for Electromagnetic Aircraft Launch System, represent a generational leap over traditional steam catapults. They're more efficient, require less maintenance, create less stress on aircraft airframes, and can launch a wider variety of aircraft types. The United States spent years and billions of dollars developing this technology, and even then faced significant teething problems when it was first deployed on the USS Ford. China appears to have not only mastered this technology, but is now standardizing it across its new carrier designs, a remarkable achievement in such a compressed time frame. The aircraft elevator arrangement is equally thought through. Current analysis suggests 3 elevators, 2 positioned on the starboard side, the right side of the ship when facing forward, ahead of the island superstructure, and 1 on the port side aft, at the rear left of the vessel. This configuration optimizes the flow of aircraft from the hangars to the flight deck, minimizes interference with landing operations, and provides redundancy should one elevator fail or require maintenance. But perhaps the most crucial component is what you can't see from satellite photos, that nuclear reactor. The reported 125 megawatt output represents not just propulsion power, but also electrical generating capacity. Modern carriers are essentially floating cities that require enormous amounts of electricity for radar systems, electronic warfare equipment, defensive weapons, aircraft preparation systems, crew facilities, and dozens of other systems running continuously. That extra 25 megawatts compared to American Nimitz-class reactors might not sound like much, but it potentially allows for power-hungry systems that conventional reactors couldn't support. Advanced radar arrays, directed energy weapons, or future technologies we can barely imagine today. Here's something crucial that often gets overlooked in discussions about aircraft carriers. They never operate alone. A carrier is the centerpiece of a battle group, a coordinated fleet of supporting vessels that work together as an integrated combat system. China's Type 004 won't sail solo. It will operate as part of a comprehensive task force, and the composition of that group tells us a lot about China's broader naval ambitions. At the heart of the escort fleet will be Type 055 destroyers, some of the most capable surface combatants in any navy worldwide. These aren't your grandfather's destroyers. At roughly 13,000 tons displacement, they're larger than many nations' cruisers. They bristle with 112 vertical launch cells capable of firing a variety of missiles, anti-air, anti-ship, anti-submarine, and land attack weapons. Most significantly, these destroyers can carry hypersonic anti-ship missiles with reported ranges exceeding 1,500 kilometers. Think about what that means. A Type 055 can engage enemy vessels, including potentially enemy aircraft carriers, from distances beyond the effective range of most carrier-based aircraft. It flips the traditional carrier warfare equation on its head. The battle group will likely also include Type 052D destroyers, providing additional air defense and anti-submarine capabilities. Type 054A frigates, specializing in anti-submarine warfare, and Type 093 nuclear attack submarines, prowling beneath the surface to guard against enemy submarines and surface threats. Supporting this combat power will be a logistics tail replenishment ships carrying food, spare parts, ammunition, and aviation fuel for the carrier's aircraft. While the carrier itself doesn't need refueling, it still needs supplies for its crew and aircraft, but notably fewer supply ships than a conventional carrier battle group requires. This integrated force multiplies the carrier's effectiveness. The destroyers extend the battle group's engagement envelope to hundreds of kilometers. The submarines provide an invisible defensive screen. The combination creates a layered defensive system that's extremely difficult to penetrate. And remember, China isn't building just one of these battle groups. They're building the capacity for multiple carrier groups to operate simultaneously, a level of naval power that only the United States has maintained since World War II. Let's return to the question that puzzles so many observers. How did China compress what took America 40 years into roughly 2 decades? The answer isn't simple, but several factors contributed to this accelerated timeline. First, China didn't start from zero. While they lacked carrier experience, they had decades of nuclear technology development through their nuclear weapons program, nuclear power industry, and nuclear submarine fleet. The Type 093 and Type 094, nuclear submarines, operational since the mid-2000s, proved China could design, build, and operate marine nuclear reactors. Adapting that technology for surface ships, while challenging, wasn't starting from a blank page. Second, China benefited enormously from technology transfer and espionage. This isn't speculation, it's documented. Chinese intelligence services have targeted Western defense contractors for decades, seeking technical data on everything from aircraft carrier design to reactor specifications to electromagnetic catapult systems. While China's engineers still had to turn stolen blueprints into working hardware, no small feat, it eliminated countless dead ends and false starts. Third, China's centralized governance model allows for sustained, long-term investment without the political cycles that plague democracies. When Chinese leadership decides aircraft carriers are a strategic priority, funding flows consistently year after year, decade after decade. There's no risk that a new administration will cancel programs mid-development or that budget battles will slow progress. Fourth, China leveraged its massive shipbuilding industry. Chinese shipyards are the largest in the world, producing more tonnage annually than the rest of the world combined. This industrial capacity, originally built for commercial vessels, provides infrastructure, expertise, and workforce that can be redirected toward military projects. Finally, and perhaps most importantly, China focused relentlessly on learning and iteration. Each carrier generation incorporated lessons from the previous one. The Liaoning taught them basic carrier operations. The Shandong, their first indigenous carrier, refined the design and proved they could build these vessels themselves. The Fujian introduced electromagnetic catapults and a more advanced design. The Type 004 represents the culmination of this learning curve, taking everything they've mastered and adding nuclear propulsion. This isn't magic. It's focused industrial policy, sustained investment, technological borrowing where possible, indigenous innovation where necessary, and an unwavering commitment to a strategic goal. The Pentagon isn't taking this lying down. American defense officials, while publicly maintaining confidence in U.S. naval superiority, are privately acknowledging that the competitive landscape has fundamentally changed. For decades, essentially since World War II, the United States enjoyed uncontested supremacy in carrier operations. American carriers could operate virtually anywhere in the world with minimal risk. No other nation possessed both the carriers and the supporting infrastructure to challenge them effectively. That era is ending. Current projections suggest China could operate up to 10 carriers with full aviation combat capabilities by 2030. If even half of those are nuclear-powered, we're looking at a naval force that can maintain persistent presence across multiple ocean basins simultaneously, something only America has been able to do for the past 80 years. This creates profound strategic challenges for U.S. military planners. American carriers must now contemplate operating within range of increasingly sophisticated Chinese anti-ship missiles, including hypersonic weapons that can strike from thousands of kilometers away. The old assumption that carriers could operate with impunity beyond the reach of land-based threats no longer holds. Moreover, China's carriers don't need to be superior to American carriers. They just need to be present. A Chinese carrier battle group positioned in the South China Sea or near Taiwan doesn't need to win a hypothetical battle against the U.S. Navy. Its mere presence complicates American operational planning, forces the dispersal of U.S. forces, and creates political hesitation about potential military interventions. This is the essence of anti-access and area denial strategy, and China is building the hardware to make it reality. The U.S. response includes accelerating its own carrier construction, though American shipyards work far more slowly than their Chinese counterparts, developing new anti-ship weapons, investing in unmanned systems, and working to maintain technological edges in areas like submarine warfare and electronic warfare, where the U.S. still leads. But make no mistake, the comfortable gap that has existed for decades is narrowing rapidly. A carrier is only as capable as the aircraft it launches. So what will fly from the Type 004's deck? The most likely candidate for the primary fighter is the J-35, China's stealth fighter designed specifically for carrier operations. If that designation sounds familiar, there's a reason. The J-35 bears a striking resemblance to America's F-35. An intelligence assessment suggests Chinese cyber espionage played a role in its development. Regardless of its origins, the J-35 represents a quantum leap for Chinese naval aviation. It's a fifth-generation fighter with stealth characteristics, advanced sensors, and the ability to operate from carriers using either ski-jump takeoffs or electromagnetic catapults. Combined with indigenous air-to-air missiles and anti-ship weapons, it gives Chinese carriers a combat punch roughly comparable to what American carriers achieved just a few years ago. But China isn't stopping there. Reports have emerged about a sixth-generation fighter program, sometimes called the J-36, that could begin entering service by the end of this decade. If China succeeds in fielding a sixth-generation carrier-capable fighter before the United States, which is still developing its own sixth-generation concepts, it would represent an unprecedented reversal in the technological balance.